Hey guys! I'll be going through how to write balanced chemical equations for Level 1 Science. This is a really handy skill to have, especially if you're considering doing the chemistry external at the end of the year. So the first example I'll be going through with you is the reaction between potassium hydroxide and hydrochloric acid. Okay, so the first step is to get the formula of your reactants. So the formula for hydrochloric acid is HCl. Make sure you learn the formulas of the acids. They aren't given to you in the exam, and they can get really confusing. So for potassium hydroxide, potassium is in group 1 of the periodic table, which means it has 1 electron in its valence shell. This means that when it undergoes a reaction, it's going to lose that 1 electron, giving it a charge of +1. So we know that it has a charge of +1. So hydroxide is a polyatomic ion that has a charge of -1. Polyatomic ions, I'm not sure whether they're given to you, but they are absolutely crucial, so make sure you know them. So potassium has a charge of +1 and hydroxide has a charge of -1. So the final formula for potassium hydroxide is going to be KOH because you only need one of each to balance the other out. Remember that all ionic compounds are neutral. So now we can begin writing our equation. So we have KOH and HCl. So it's best now to write out everything you've got. So we've got a Cl minus, an H plus, an OH minus, and a K plus. Remembering that OH minus is basically one block. So Cl minus, let's start here. The Cl minus is not going to be bonded with hydrogen on the other side of this equation, because if it was, then that would mean that no reaction has occurred, and we know for sure that something is definitely happening. So we know that it's not going to be with hydrogen. And since it's got a negative charge, and all ionic compounds have to be neutral, it's going to want to bond to something positive to balance it out, which means we can cross off OH minus off the possibilities as well, which basically just leaves us with potassium. So now we know that potassium and chloride are going to bond together during the reaction. And since potassium has a charge of +1, chloride has a charge of -1. The final formula for potassium chloride is going to be KCl. Okay. So now all we have left, we've used up our chloride and potassium, so all we have left is 2 hydrogens and 1 oxygen. And that should automatically click that it's going to be water, H2O. And we can check that with the 3 rules you'll come across in your external. You would have gone over these in class. We can see here, a metal hydroxide plus an acid will always result in salt and water. And that's exactly what we're seeing here, so we can tick that off. And just make sure you do a double check to make sure it's all balanced. So we have 2 hydrogens on both sides, 1 oxygen, 1 chloride, and 1 potassium. So it's all balanced, and that's the final equation for the reaction between potassium hydroxide and hydrochloric acid. Okay. So now I'll be going through the reaction between sodium carbonate and nitric acid. Okay, so this is a bit more tricky. Go ahead and try it yourself if you like. So step 1 is to get the formula for the reactants. So the formula for nitric acid is HNO3, and as I mentioned before, the formulas for the acids can get confusing, so make sure you've learned them. The formula for sodium, it's also in group 1 in the periodic table, which means it has 1 electron on its valence shell, and that means that it's going to have a charge of +1. Carbonate is again a polyatomic ion, so it's going to be CO3 2-, and there isn't really a handy way of figuring that out. Again, not sure whether it's given to you in the exam, so just make sure you're familiar with them and their charges. Okay, so since Na has a charge of +1 and carbonate has a charge of 2-, you're going to need 2 NAs to balance out the 2- charge of CO3. So it's going to be Na2CO3. Remember, this small subscript 2 indicates that there's 2 NAs. Okay, so now we can begin writing our equation. We've got Na2CO3 plus HNO3. Okay, so now it's best to look at what we have again. We've got our NO3 minus H plus, and remember, since it's H plus, then that means that NO3 must have a minus charge. And then we've got Na plus, and we've got 2 Na plus. Don't forget that. That is absolutely crucial that we've got 2 of them. And we've got a CO3 2-. Okay, let's start with NO3-. So it's not going to be with hydrogen, and it's not going to be with the carbonate. As I said before, it's going to want to be with something positive, and that's not hydrogen because it's already with hydrogen. So it's going to bond with Na. Since Na has a charge of +1 and NO3 has a charge of -1, you're just going to need 1 to make the formula neutral. So it's NaNO3. So we've used our Na, and we have only used 1 Na. We've used our NO3, sorry, and we have only used 1 Na. We'll come back to that later. Okay, so now we basically just need to use our hydrogen and carbonate. This is where it gets tricky. We've got our 1 hydrogen and our 1 carbonate. If we go back to our rules, we can see that every metal carbonate plus an acid will always equal salt and water and carbon dioxide. Looking at what we have left over here, we've got 1 hydrogen and 1 carbonate. But if you think about it, carbon dioxide's formula is CO2, which means that we've got a CO2 and we've got an oxygen and a hydrogen. So basically we're going to have plus CO2, that's balance, plus H2O. And now this is the bit you have to be really careful. You've got to know what you're doing. So we've used 1H, and we've used everything here. But now we've got an extra H plus on this side and an extra Na plus on this side. So basically, you can see already that it's not balanced. This is not the correct equation. So let's start with NaNO3. We know we have 2 NAs, and Na can only go to NO3, which means that there's got to be 2 NAs. But I cannot write Na2NO3 because that completely changes the molecule and therefore changes the charges, and it just makes an incorrect charged particle, which is not what we want. So basically we have to add a 2 at the front, which tells us we have 2 sodium nitrate molecules. That's a 2, sorry. Yep. But now we have an extra NO3 on the side as well, although we've used our Na. So we've got our extra H plus and an extra NO3. And we can see that nitric acid is made up of H plus and NO3. So we basically, this is a fairly simple. We just have to add a 2 on the front there to show that we have 2 nitric acid molecules. And then that balances out our equation. We can double check it. We've got our 2 NAs. We've got 1 carbon. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens on this side. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens on this side. 2 hydrogens and 1 NO3 on each side. So yeah, it's basically balanced, and we've already checked it with the rules and they definitely follow them. So this is the correct equation for the reaction between sodium carbonate and nitric acid. So that was a really tricky one, so well done if you got that correct. Thanks for watching.